All right, so today's lesson is on inequalities involving absolute value. But before I start the lesson, we're going to do a little discovery activity to see if you understand the value, what it really means to have absolute value. Okay, so here's a table. Here are the values of x. Okay, when I plug in these values into this expression, absolute value of x, remember we learned this earlier in the year that anytime I have an absolute value, my value is always positive because it represents the distance that number is from 0. So when I plug in all of these numbers, my answer should always be positive. Okay, so then I'm going to plug this in. I'm going to plug in this value into here. Okay, so tell me, true or false? Is 4 less than 2? That's false, right? What about this one? Is 4 greater than or equal to 2? That's true, right? Now let's plug in 3. Okay. Is 3 less than 2? False. Is 3 greater than 2? True. Now let's plug in 2. Is 2 less than or equal to 2? Well, that's true because it's equal to 2. Now let's plug in 2 again here. Is 2 greater or equal to 2? It's equal, so it's true. Now let's plug in the 1. Is 1 less than or equal to 2? Well, that's true because it's less than, okay? What about here? Is 1 greater than 2? That's false. 1 is not greater than 2, okay? What about 0? Okay, is 0 less than 2? That is what? True, right? 0 is less than 2. What about is 0 greater than 2? False. Okay, so now let's plug in 1 again. Is 1 less than 2? True. Is 1 greater than 2? False. Okay, now let's plug in 2. Is 2 less than 2? Is 2 less than or equal to 2? True. And this would be true also because it's equal. Is 3 less than 2? False. Is 3 greater than 2? True. Is 4 less than 2? False. And is 4 greater or equal to 2? True. Okay? So now, let's graph. Okay? So, x, the absolute value of x is less than or equal to 2. Okay? This is my statements. Okay? So, let's see. Where is it true? From -2 all the way to +2, right? So from -2 all the way to +2, it is true. But it's false at -3, -4. It's false at 3 and 4. False. So I can't shade that. Okay? Sorry about that. So again, where did I get this? From this table. Where is it true? It's true from here. That's from -2 all the way to 2. That is true. So I'm shading from -2 to 2. I can't shade over here because it was false there. Okay? So now tell me, which statement, okay, does this graph resemble? Is this graph resemble an and or an or? And I hope you said and, because we know ands represent everything in between, okay? Or is usually everything opposite. Okay, so let's do now this graph, okay? Again, where am I gonna grab my information? From this table. So let's look at where is it true. It's true from -2, -3, and -4. So I'm gonna go on my graph at -2, it is true from -3 and -4, okay? So now let's do this one. So then where does it start again for true? Here, here, and here. So it starts at +2 and is true for 3 and 4. So look at the graph, okay? So what statement does a greater represent? An or statement. So for graphs, okay? So for an absolute value inequality that has a less than or equal will represent an and. Your graph should look like this, everything in between, okay? For a greater than or equal will represent a statement of an or. So your graph should be going opposite direction. So as you can see, okay, when I am given absolute value inequality, I should end up with 2 endpoints. That represents that when I see an absolute value inequality, I'm going to have to rewrite it into 2 inequalities. So for example, this one, okay, will be x is less than or equal to 2 and x is greater or equal to -2. Because at -2, I'm going to the right. That means greater or equal to. At 2, I'm less than. So basically what you're doing is you're identifying which statement it is. You keep the original one the same, and then you flip, and the number becomes its opposite for the second one. Okay, look at this one. Okay, greater represents an or. All right, so x is greater or equal to 2, or x, flip it, and it becomes -2. Okay? All right, so this is your discovery. So now you understand where the and the or are all coming from. Okay? So now let's do more examples. Okay? So here. So again, let's just recap what we got from the discovery. Okay? So from the discovery activity, what did we conclude? That when we have a less than or equal, it represents an and. Okay? When we have a greater than or equal, I'm going to have an or statement. All right? So let's look at example 1. All right? Your first step that you should do, okay? First of all, the absolute value is by itself. This represents an absolute value. That tells me I should have 2 inequalities. Remember, you switch direction, okay? So you first circle this. This is a less than. I know I should have an and. So I'm going to keep the first one the same, okay? Do not change anything. Then I'm going to write my statement, which represents an and statement, all right? And then when I write the second one, I need to flip the symbol, and my 2 becomes its opposite. Because remember, when we're dealing with the absolute value, it represents the distance that you're traveling on the number line. So you have to flip the symbol because you're changing direction of your shading, okay? So this is what we have to write too. So now all you do is solve for x. So I'm going to add x here, a here. I get this. And add 8 here, and I get x is greater or equal to 6. But because this represents an and, I need to put my x in the middle. My smaller number should always go to the left, and the greater number should always go to the right. So see, it says x is greater or equal to 6, so x is greater or equal to 6, and x is less than or equal to 10. So when I graph it, when I draw my number line, I'm going to start at 6, 7, 8, 9, 10, 11. Let's put a 5 here. This is closed circle. And this represents everything in between. So this is what I want to see for the classwork. I want to see you identifying which statement this represents. Does it represent an and or an or? Write 2 of them. Make sure the second one you flip the symbol and the number becomes as negative. You solve. You bring this together if it's an and then you graph. And your number line has to be labeled. All right? So let's do another. Again, this is a less than. So this represents an and. So I'm going to rewrite the original one. Or actually, take that back. See how it's easy for you to mess up? Okay, let's go back to this problem. Absolute value. We understand that absolute value always gives you a positive number because it represents the distance. So can I solve this one? I can't solve this one because this tells me that my distance is negative. Because remember, absolute value is equal to the distance. So my distance can be negative. This is no solution. I cannot solve this. Okay, it represents an empty set. Okay, so that's very important. Your absolute value cannot equal to a negative number. Okay, so you see, I was about to solve it, but until I really looked at my number. All right, so let's do this one. I first look at my inequality is a greater. So I know this is going to represent an or statement. So my first one will stay the same. Then I write the or, and then I'm going to rewrite the second one, flip the symbol, and the 7 becomes negative. Now I'm going to solve my inequality to get the x by itself. So I'm going to subtract 1 here, divide by 2. I get x is greater than 3, or, okay, subtract 1 here, divide by 2. Okay, so I get x is greater than 3 or x is less than 4. That tells me that when I draw a number line, okay, I'm going to put the 0 in the middle. 1, 2, 3, 4. And then my negative's on the left side. Okay, this should be an open circle at both. This is greater. And this one says less than. So they should be going in opposite direction. Okay, and that's my solution. And for this one, what do I see? Is equal to a negative. I cannot solve it. I don't waste my time. All I need to write is no solution. So that was today's lesson, is you being able to identify what statement the absolute value inequality represent. Does it represent an and or an or? You should end up with 2 inequalities and 2 endpoints when you graph. So I assigned 4 classwork problems to do, and plus the quizzes. All right, so if you have any questions, just email me or ask me during our Zoom meeting.